Let's open up the consultant salaries dataset and take a look at it. We'll double click on it, change its name to consultants, and run our import step. Here is our output data. We have the initial salary for a bunch of these consultants. We have their salary after 1 year. We have their gender, and we have the percentage raise that they received. Now, we've been told that our consultants usually receive an 8% raise after the first year. So our first task is going to be to determine whether we have evidence against this claim. So we're going to go down to tasks and utilities, statistics, and t-tests. T-tests are what we use to test simple claims like this. Change our data set to the consultants one. And now we're going to run a one sample t-test on the raises in order to see whether we can prove anything in particular about whether or not these raises are 8% in the first year. We need to go into options, and we're presented with the various types of t-tests that we can perform. We can perform a two-tailed test, an upper one-tailed test, or a lower one-tailed test. Okay, so what are we looking at here? A two-tailed test tests whether something is equal to a particular value versus the alternative that it is different from that value. What's the next one? An upper one-tailed test is going to test whether a particular population parameter is greater than some theorized value or not. A lower one-tailed test is going to test whether some population parameter is lower than some theorized value. So now what have we got here? If we read just up above in that t-test for consultant salaries text block, it says the firm makes the claim that raises are usually 8% after the first year. Okay, well that doesn't say anything about whether it's 8% or greater, 8% or less, it just says 8%. So our alternative hypothesis should be that raises are different from 8%, which means that evidence either above or below would convince us that our null hypothesis of an 8% raise is incorrect. So that tells us we should be using a two-tailed test. Our alternative is that mu, the average raise, is not equal to this 8% level. Okay, let's run our test, see what we get. We can ignore the first part here. These are tests for normality that we can use to test whether the variables come from a normal distribution. Our t-tests are not particularly sensitive to this, so we're not particularly worried about the fact that these all say that this is not a normal distribution. If we have a look down here at the data, yeah, I mean, it's a little bit abnormal, a little bit far from a normal distribution, like that nice blue line there would be. But it's not too far away. It's basically mound-shaped, so we're safe to use these t-tests here. What did we get as our average raise? We got an average raise of 7.59%. Well, that's less than 8, but is it far enough less than 8 that we should disbelieve that the true average raise is equal to 8%? That's what our p-value is going to tell us. So as we work through here, we've got a mean of 7.59. We have a standard error, that is the standard deviation of this test statistic, of 0.13. And so we can think, okay, how many standard errors is this 7.59 away from the hypothesized value? So we would do 8 minus 7.59 gives us 0.41. We divide that by 0.13 and we get a value of around 3. Jump down here and that's exactly what we've got as our t-statistic. We have a t-statistic of about 3. In fact, it's minus 3 because our observed value is lower than our hypothesized value. Now, is this far enough away from 8 for us to say, yeah, we've got evidence that the true average raise is not 8%? In fact, yes, we do. Our p-value down here tells us that our chance of having observed a test statistic this extreme, if the true value for the average raise was 8%, the chance that we would observe a value this extreme, like 7.59, is only 0.003. 3 out of 1,000 times we would see a test statistic this extreme. That's too little of a chance. Typically we use the 5% threshold to say if we see something with a p-value, a chance of having seen it less than 5%, we're going to say that's unrealistic. We should believe that the alternative hypothesis is true, and that's what we would conclude in this case, that the actual raise is not equal to 8%.